All right, it's been a while, but I'm gonna try and make whatever this is a little easier if anyone's confused. But basically, first, um, these are things that you have to understand, but there are a few things to memorize, which will make these problems a lot easier. And that would be memorizing what you're adding. So like water, sodium chloride, glucose. All you have to know is whatever you're adding, is it hypoosmotic, hyperosmotic, or isoosmotic? And that will determine what happens, and then you can figure out what happens next. So for this first problem, you're adding 2 liters of water. So you should know by memorization that water is hypoosmotic. For any of these problems, when you add something, the volume of the ECF will go up, right? That's obvious because you're adding water in. So you would expect the volume of this side, the ECF, to increase. And that's shown by this right here. Because this is where you originally were, right? You were originally this. You add 2 liters of water, so it's going to expand outwards. But you're wondering, why does it go down in level? So level is like the osmotic pressure or whatever, concentration. And the reason why it's going down is because water that you're adding is hypoosmotic, so you're kind of diluting this side. So you increase volume and you diluted it. And the thing is, when you increase volume, osmolarity goes down, right? And now the osmolarity goes down, you're going to have fluid move into this side to balance the osmolarity. And then you end up with extra volume on this side. So the order is you add water, which increases this. Because it's hypoosmotic, concentration goes down. And whenever concentration goes down on this side, it will always move to this side and increase volume. Does that make sense? Okay, we'll try another one just to make sure. So adding 2 liters of 0.9% NaCl. Again, you can only answer these if you know if these are hypo, iso, hyperosmotic. I think there's a way to calculate it, but you can just memorize it to make it easier. So I know 0.9% NaCl is isoosmotic, which means it will not be changing what part of this? It won't be changing this level, because remember, this level is the osmotic. Remember, on this one it was hypo, so we lowered it. Okay, so because we're not changing this level at all, we're just adding 2 liters of something, right? So what would change? You would have increase in volume. Would it be increase in volume on the ICF side or the extracellular? When you add, it goes to the extracellular, right? It doesn't move inside the cell, you're adding outside. So you're just gonna have increase in volume on the extracellular side. Nothing else changed. No concentration changed, nothing moved, because it's isoosmotic. So nothing else had to happen besides just extra fluid. Okay, now let's try glucose. So 5% glucose, you should also know, is isoosmotic. And what does it mean if it's isoosmotic? Remember, that means that you're not changing any concentration. You're going to keep that the same, which means you're not going to have a drop in level, none of this. It's going to stay at the same level. And remember, if you're adding something, it goes to the ECF side, right? So on this side, the E, you're going to have increase in volume, which is shown by that going to the side right there. Boom. And remember, concentration is the same, so you're not going to have any fluid moving to balance things out. Because remember, it moves based on where osmolarity is, right? But because you're good, you just add this. Even though you added it, everything's still the same, so everything's good. Just increase volume. But you must know, for glucose, 5%, the thing is, when you add glucose, it instantly metabolizes from glucose to water. And what do we know about water? Remember, from the first problem, water is hypoosmotic, right? Which means if you add it, what's going to happen if it's hypoosmotic? It's going to bring the concentration down. So now that osmolarity is down on this side, on the ECF side, osmolarity dropped. Remember, fluid always flows to the side with higher osmolarity. So in relation, because it dropped on this side, that means this side is higher osmolarity, right? And to dilute it, to balance things, water will move from ECF over to ICF just to balance the osmolarity. Remember, you should already know that. So this dropped, fluid goes to this side to balance it. What happens when fluid moves? It's not complicated. You don't have to overthink it. Because fluid moved over here to the side with higher osmolarity, then obviously the volume on this side is going to increase because you already moved over. So just to remind you, remember the order is osmolarity dropped, fluid moves over to balance it. Because fluid moved over, you're going to have increased volume on the ICF side. But just to make it more simple, you can memorize that 0.5% glucose is the same as H2O outcome. So instead of going through the whole process of this happens here and then this metabolizes and it gets here, you could just memorize that water, 5% glucose, will give you the same outcome. But that's the mechanism if you want to understand it. Okay, here's the last one. Which of the diagrams below represents simple dehydration caused by water loss? So let's think about it. I didn't look at this yet, but let's see. So dehydration would mean you lose volume, right? So let's think it through. If you lost volume, I would assume you lose it from the ECF side, right? So this ECF, and then I would imagine it goes in this way, because I'm moving this way to the sides, increasing volume, moving this way. So I would think it's like this, right? So what happens once you lose volume? Let me think. So if you lose volume on ECF, I would assume that it got less diluted. So pressure, or what do you call it? The gradient would go up on this side, osmotic. So you would increase, and because it increases on this side, then fluid would move over. And then you'll lose fluid on this side because it moved over. But let's see if that's correct. So let's see if the thinking was correct. So first, ECF loses volume. That's the first thing that happened because the problem said dehydration. And then when you lose volume, you increase osmolarity. That happens next. It goes in order. Remember, you must know what happens when you increase osmolarity. You're going to have water moving towards the side of increased osmolarity, right? So because this increase, you're going to have water moving over here from ICF to ECF. And when water moves this way, then you expect osmolarity to increase, right? But you already knew that from this side. Okay. But the flow is when water moves this way, then you lost water on this side. So basically the water over here went over here. That's why you lost it. Does that make sense? I feel like that might have been confusing, but I'll run you through the order anyways. And even if some part of this is confusing or you have some questions, just know that whatever I wrote here, the thinking process would work for the problems. So just follow it. So the question said, dehydration. Dehydration, you lose water from which side? I or E? You lose it from the extracellular side. And that's shown by, boom, here, you lost volume. When you lose volume, osmolarity increases. When osmolarity increases, when you have any change in osmolarity, then you have fluid moving towards that side to fix that issue. So you can balance osmolarity on both sides. That's why you had it high on this side, and then when it moved over, this went up to match it. And then when this moved over, you lost volume on this side. Okay, that's all.